Before proceeding with the installation, configuration, operation, or maintenance of these products, please ensure you have thoroughly reviewed all relevant documentation provided by Balluff and other pertinent sources, including installation guides, configuration manuals, and operational protocols. It is essential for users to adhere strictly to all applicable codes, laws, and safety standards during installation, wiring, adjustment, and operation. Installation, configuration, use, assembly, disassembly, and maintenance of these products must be performed by individuals who have received appropriate training and are fully versed in following the outlined procedures and safety measures. Failure to comply with these prerequisites may result in noncompliance with legal and safety standards. We expressly disclaim any liability or responsibility for damages, whether direct, indirect, special, or consequential, arising from the use or application of the information contained herein. Balluff Inc., in no event, will be held accountable for any damages incurred as a result of using this guide. The content of this guide is intended for illustrative purposes only and does not ensure suitability for specific applications due to the diverse range of variables and requirements in different scenarios. Users are entirely responsible for verifying the applicability and safety of this information for their unique situations. Acceptance and use of this information come with an understanding that any and all risks associated with the installation, configuration, assembly, or use of these products are fully assumed by the user. Please note that this document does not serve as a warranty of any sort, nor does it modify or supplement any valid warranty provided by Balluff, Inc. for these products. The information herein supplements the original warranty terms without altering them.
In this video, we will go over how to read and write ISDU I/O link parameter data on a Modbus TCP I/O link master module from Balluff. Our network layout consists of having a Balluff Modbus TCP I/O link master module connected to a PC running Modbus TCP client software. Connected to the I/O link master module in the first I/O link port is a Balluff I/O link condition monitoring sensor. Connected to the second I/O link port is a Balluff discrete I/O link hub. All Modbus register reads will use the Modbus function code 03 read holding registers. All Modbus register writes will use Modbus function code 16 write multiple register command. This table shows the specific I/O link parameter ISDU command to read and write, along with the Modbus registers to read the response of the I/O link master. For an ISDU parameter read and write, you would access Modbus register 100. For a read command, you would put a value of 1 into register 100, or you would put in a value of 2 for any write commands. At Modbus register 101 would be the port on the I/O link master of the I/O link device you want to read or write. Valid values on a Balluff I/O link master would be ports 1 through 8. Next is the index and subindex of the parameter on the I/O link device. Always refer to the user manual of the I/O link device to find the parameter and its index and subindex value. For the read command, the data length in Modbus register 104 would be left at 0 and no bytes would have to follow. For any write commands, the data length of the parameter you want to write along with the data would follow that command. The response from the Balluff I/O link master module will always start at Modbus register 300. If the command, port, index, and subindex values are echoed back from your read or write request. If there's an error, the error code from the Modbus register would start at 304. Otherwise, the return data length would start at Modbus register 305, and the data then gets returned at Modbus register starting at 306. To look at the response from our read command, we can start looking at register 300. In this case, you could see that in the response, register 300, 301, 302, and 303 is the same values that were echoed in our command. 304 shows a value of 0, which means there's no error codes that gets returned. The data length in the application-specific tag is 32 bytes, so that is our response in register 305. In register 306 and 307, we will see the value that's returned in our IO-Link hub. In this case, the value of 1234 that's in our IO-Link hub is shown, but since the value is in ASCII, the response shown is in hex. So we could see that 3132 is in register 306, and hex 3334 is in register 307. Next, we'll issue a write request to an ISDU parameter data. In this example, we would write to the IO-Link discrete hub subindex 0 index 41 to configure your inputs and outputs on the discrete hub. We would issue a Modbus function 16 write multiple register command. At register 100, the value would be a 2 for a write command. The port would be 2 in this case, since the IO-Link discrete hub is plugged into port 2 on the IO-Link master. The index is 41 hex or 65 decimal. The subindex is a value of 0. In register 104 would be the data length that we're sending. In this case, the data length has a value of 2. The value that we wish to write in register 105 would be combined for byte 0 and byte 1. In byte 0 is the port direction for each of the 8 ports for pin 4. In byte 1, that would be a port direction for pin 2 on the 8 ports. We could always write this value in hexadecimal to make it easier. So for example, if we wanted to write the byte 0 a value of FF, that would turn all port 1 through 8 pin 4s as an output. Then the 00 in the high byte, or byte 1, would show that pin 2s are all set up as inputs. Once this is set up, we could hit the send command to send this command through. We get a response back that the write multiple operation is successful. We can then go into Modbus register 300 to read back the values using a read holding register. From here, you could see that at register 300 through 304, those are the commands that were sent back and it's echoed back. 304 shows its value as 0, which means that there is no error code and this command went through successfully. 306 shows the data byte that we wrote, which is FF, which configures byte 0 for all pin 4s to be set up as an output. We can also look on the web server of the Modbus master, and then when we go and look at your port direction, we could do a read all on the IO-Link discrete hub. From here, it returns back at port 0 that pin 4 is set up as an output, and direction on pin 2 is set up as an input. We could do the same thing for port 1, all the way up to port 7. So we could see that we have successfully written and set up the ISDU command for port direction on pin 4 as an output.